In this lesson, we're going to be reviewing some information related to something called kinetic molecular theory, or KMT. This explains what an ideal gas is like. We're going to go over some criteria that you're going to need to know. The first thing is, under this theory, say that gas particles essentially have zero volume or neglectable volume. We basically, when we're measuring the volume of a gas, we're really measuring the space between the gas particles because the particles themselves are so tiny that really it's insignificant. This is also why gases can be easily compressed. So it's a common phrase related to KMT that the volume of the gas particles themselves is neglectable compared to the total volume occupied by the gas. All right, for number 2, you need to know that under KMT, gas particles do not attract each other. So ideally, they have zero IMFs between them. So this is one essential part of this kinetic molecular theory that you need to know. Number 3, you have to know that gas particles are going to move in random, constant, straight line motion until they either hit another particle or they hit the side of the container. Number 4, we say that gas particles are perfectly elastic. What elastic means is that they're going to lose no energy when they collide with one another or with the walls of the container. Now, two gas particles, when they collide, they can transfer energy perfectly between them. That means that there's energy is conserved and that no energy was lost to the environment. So usually the one that has the greater amount of energy will transfer some of its energy to the one with the less amount. But it's a perfect transfer, nothing lost to the environment. And lastly, with number 5, you need to know that as the temperature increases, this is due to the gas particles moving faster. Great. Now, part of KMT is knowing what ideal gas behavior essentially occurs at, and this is something you have to memorize. You need to know that under conditions of high temperature and low pressure, molecules are going to behave most like an ideal gas. So this comes up in multiple choice questions all the time. It will say, which of the following conditions will this gas behave most ideally? And you're always going to look for the highest temperature and the lowest pressure. Also, the lighter the gas molecules are, the more ideally it will behave. So hydrogen and helium are gases that are most ideal because they're so light. All of these conditions basically minimize IMFs, which allows it to be most like an ideal gas. So real gases, what we actually have to work with in the lab, these are basically going to fail to exhibit their ideal behavior if it's at a low temperature and a high pressure, so basically the opposite. This causes the particles to attract each other, so they're not going to be able to obey the gas laws completely. So real gases, or when a substance acts most like a real gas, you're going to be looking for low temp, high pressure. Alright, one last little piece of information that's a pretty critical one, especially in terms of a multiple choice question, is knowing and understanding something called Avogadro's law. What this means is that under the same pressure and temperature, identical volumes of gases must contain the same number of particles. So for example, if I have a gas below that contains the same number of molecules as 2 liters of O2 at 30 kelvins and 100 kilopascals, if they have the same number of particles, have to have the same volume, the same temperature, and the same pressure. So the only one that matches that criteria of the O2 would be letter C, the sample of F2 that has the same volume, the same temperature, and the same pressure. So basically, if 3 of the 4 are the same, temperature, pressure, volume, or number of particles, the force must be equal. When we look at Avogadro's law, we're going to be looking at the fact that temperature, pressure, and volume have to be the same in order for them to have the same number of particles. And I'll give you a bunch of examples of this tomorrow so you can see how this plays out in a multiple choice question. You are all set.